各位同学好，欢迎来到电磁理论的课程。Welcome to the course of electromagnetic theory. This is the course syllabus and the course overview. This course will be taught by me, Professor Wen-Jiao and Professor Wen-Jiao. And here's the meeting schedule. We will meet every Monday from 9:10 to 12:10 at this classroom, EE5306701. And the objective of this course is to present an introduction to the theory and application of time harmonic electromagnetics, that is, based on a continuous wave of radio frequency. Important EM concepts including Maxwell equations, boundary condition, the wave equation, the propagation and the formation of plane waves, the concept of reflection and transmission at material interfaces, and some basic electromagnetic theory will be covered in this course. You guys should be able to learn some fundamental laws of electrodynamics, which can be derived using the Maxwell equations. So students will learn electrical properties of materials, solution of wave equations, and etc. And of course, we will introduce some advanced concepts about electromagnetics, such as the vector potential, which is very useful in deriving formulas and equations applicable to actual wave propagation. And here is the textbook of this course, Advanced Engineering Electromagnetics, which is written by C.A. Blanes. I strongly recommend you guys to get one copy of this textbook, which is available at Oya Shuju. And here's the telephone for the bookstore. And the course will be conducted in English, of course, and I will provide some video clips conducted in Mandarin because I guess most of the students are from local, so it's kind of a supplement materials. I have told this slides a few years ago, so you can also go into these slides using Mandarin. And we will have homeworks, weekly homeworks, and of course they should be submitted and graded. That will be part of your semester grades of this course. And here is the lecture schedule. We will cover 8 chapters from the textbooks, beginning from Maxwell equation, chapter 1. Chapter 3 is wave equations and solutions, and chapter 4 is plane waves and polarization properties, and chapter 5 is what happens at the material interface, that is, the reflection and transmission phenomena. In chapter 6, we will introduce the concept of vector potentials, and in chapter 7, we will cover several important electromagnetic theories. And in chapter 11, we will discuss scattering, which is one important phenomenon that you observed for wave propagation. And chapter 13 is kind of the introduction for geometric theory of diffraction, which is the high frequency measure, which describe how we treat wave propagation in real environment using based on some EM assumptions, so that we can handle electrically large problems. We will have 2 midterms and 1 final, so hopefully we can have 3 exam grades by the end of this semester, and we will also have grades contributed from weekly homeworks, which is 20%. So here is the lecture schedule. Because of the COVID-19 pandemics, unfortunately, we have to begin the courses with online materials. That is, the first 2 weeks will be you will need to study by yourself using these online materials. And beginning from the 4th week, because we have the 3rd week off, so beginning from the 4th week, we will back to the classroom, and we will take 2 weeks to discuss about chapter 4. And on November 1st, we have the first midterm, which is closed book. It should be a closed book one. And in November 8th and November 15th, we will have cover chapter 5. And that is the first half of this course. So all the first 6 weeks will be taught by me. And after that, the second half of this course will be taught by, lectured by Professor Wen-Jiao. And so he will cover chapter 6, and at the beginning of December 6, you will have the second midterm. And then you have 2 weeks for chapter 7, 1 week for chapter 11, and 1 week for chapter 13. And then we will have the final on January 10th next year. So here are the outlines for each chapters. In chapter 1, we will. It's kind of a review of the important EM relationship we have covered in undergraduate electromagnetics. So you will review the Maxwell equation, constitutive relationships, and the boundary condition as well. And in chapter 3, we will redo the derivation of wave equations in time harmonic and in time harmonic form in particular. Okay, so that will be the general form of plane wave equations. And chapter 4 will discuss about wave propagation properties such as the phase velocity, wave impedance, standing wave ratio, and etc. We will also discuss the polarization property of electromagnetic waves. In chapter 5, we will look into the reflection and transmission, which take place at the interface of 2 materials of different EM properties. That is, different conductivity, different permittivity and permeabilities, and many interesting things happen at the interface. And in chapter 6, we will introduce an important concept, the vector potential. And we will try to use vector potential to construct the solution for electromagnetic wave propagation. And this is very important for antennas, to know the antenna's properties in the radiation properties in the far field. The vector potential is the most useful tool you can have for this. And we will discuss different kinds of electromagnetic wave modes, such as TM modes and TE modes. And in chapter 7, we will review important electromagnetic theorems and electromagnetic principles, including duality theorem, uniqueness theorem, images theorem, reciprocity theorem, and etc. We will see as we proceed to that part of the course. And in chapter 11, we will discuss the scattering properties from, say, cylindrical objects or spherical objects. This is important aspect when you look into the radar cross-section of targets. I mean, what happens when electromagnetic waves hit on particular objects. And in chapter 13, we'll introduce a high-frequency numerical method for electromagnetics, which is the geometric theory of diffraction. It begins with geometric optics. Geometric optics is very easy to understand because we use optical rays to describe the propagation of electromagnetic waves. However, those EM waves, the wavelength of EM waves is much larger than optical rays. So actually, you need some supplement terms to get a more accurate estimation of the result. So that's the reason why we developed the so-called geometric theory of diffraction to describe what happens at the edge of object. 好，那我想我们就快速的再回顾一下课程的这一个内容的重点了哈。也就是说，我们这堂课的话会由我，也就是廖文照老师以及侯元昌老师一起授课。那这门课原本都是比较早，其实我在上哈，不过因为我担任行政职的关系，这2年就没有再上这门课。那我想对于学习这个电波领域的同学来讲哈，这门课还是多多少少有它的价值存在哈。我们重点是放在电磁波在传播的时候的一些现象哈，它打到这个不同的物体的时候会有什么样的效果哈。所以我们希望在这门课里头，大家可以建立电磁传播的一些基本观念，还有一些工具的基本工具的一个原理，还有使用方法。好，所以这一页我们看到是课程的时间了哈。课本的话，非常强烈建议各位要有这本课本啊。这本课本是由 C.A. Blanis 教授所写的。那我认为他的英文非常的浅显易懂但是也非常的精炼简洁，所以我觉得是一个非常好的参考书啦所以强烈建议各位要有这一本书那最好是买正版的啦OK 好，那欧亚数据有了。好，那这是课程的所以我们大概有八个章节那当然其中4、5、6、7章的话，我们大概都会花2个礼拜来讲那第一章的话是Maxwell Equation 的回顾那第2章讲的是波动方程式，那第3章讲的是平面波的特性像是极化特性等等。那第5章的话是界面上的这个反射跟透射。第6章是所谓的 vector potential 这是在电磁传播甚至是天线设计里头一个非常重要的技巧透过 vector potential 的计算，我们可以得到原厂的辐射场型不仅仅是实际的这个天线电磁模拟，还有天线的进场量测其实都是建立在 vector potential 这个方法上面。那第7章是重要的电磁理论我们大概会看6、7、8个这一个电磁理论它如何形成的那第11章的话是散射也就是电磁波打到物体之后它所产生的这些 scattering 的散射现象。那第13章是 高频电磁方法我们主要会介绍 GTD Geometric Theory of Diffraction。好，那课程的话，我们主要就是3个期中考跟期末考那希望这学期之后都能够顺利进行了那基本上就是那一周课堂上考试那另外就是每周我会assign这个作业 homework 那它也占20%的分数。那这是我们的 lecture schedule 所以前半段的话，第1章到第5章是由我授课，那第6章到第13章是由侯教授来授课。好，那大概是这个样子。那课程的内容那我们当然是以英语授课为主那我在几年前有就这些内容有录过一些slide 那它是以中文的，那我会把连结放在 Moodle 里头那有需要的同学也可以看一下这些课程的这个影音档或许可以，只要你第一次听英文没有办法那么快速的理解或抓到重点的话，那你还有机会听这个中文的部分。好，那再来是我们的这个课程介绍。